Today, we're tackling a common yet intricate task in software engineering, determining if a numeric string is valid. This isn't just about coding, it's about thoroughly understanding and testing our solution, which is crucial in a job interview. Imagine this, you're in an interview and you're asked, can you write a function to check if this numeric string is valid? And that's it, you're given a string with no other details. This is where your analytical skills shine. It's up to you to think about what makes a numeric string valid. We're talking signs, digits, decimals, and even scientific notation like E, lowercase, and uppercase. It's your job to identify these requirements and come up with comprehensive test cases that cover all of these scenarios. So before we write a single line of code, let's brainstorm some test cases. We need examples with just signs, some with digits, others with decimals, and a few with scientific notation. Each test case should explore different combinations and edge cases. This is a critical part of the interview itself. It shows you're thorough and understand the problem deeply. Once we have our test cases ready, we'll opt for an algorithmic approach over using regular expressions. So as always, let's start with an example and work from there. Let's take this string as our example. Why? Because it has signs, digits, a decimal, and scientific notation. Everything that we need to test. At this point, there's a critical aspect we must discuss, which is the order of the signs, decimals, and scientific notation. This is a fundamental part of what we're being asked to solve. First, we must always have signs as the very first character. A numeric string can start with a sign, positive or negative, but if a sign appears elsewhere, it's a red flag. Secondly, a decimal point is like a pivot. It can appear anywhere in the number, but once it appears, it divides the number into two parts. The order is crucial here. A decimal point must be surrounded by digits. If it's at the start, the number must follow immediately. If it's at the end, it should have a whole number before it. And then with regards to scientific notation, the E, lowercase or uppercase in scientific notation signifies a shift to exponential form. And this always comes after the main number. It's like saying, here's the number. Now, here's how many times you multiply it by 10. If E, lowercase or uppercase pops up anywhere else, it's a deal breaker. Now going back to our example of negative 123.456 E10, let's figure out how to write the code. So first we initialize variables. We set has decimal and has E to false. There are trackers or checkpoints for decimals and scientific notation, and allow us to write rules around these flags. Then we check the first character. It should be a sign, digit, or decimal. If it's something else, the string is invalid. Now we traverse the string and examine each character. Anything other than digits, a decimal, or an E character means the string doesn't cut it. And we also want to watch out for multiple E's or multiple decimals. In addition, any decimal after an E is a red flag. And if all conditions are met, we've got a valid numeric string. When we test our code, that's where the earlier brainstorming pays off. And here's our function, all spelled out now. Let's walk our earlier example through the logic in the method. We start by setting has decimal and has E to false. These will help us track the presence of a decimal point and the E character. The first character of our string is negative. Since it's a valid sign, our function continues without any issues. Next, we move through each character. The string has digits 1, 2, 3, 4, 5, 6, 1, 0, a decimal point, and an E. So each character is valid according to our rule here. As we encounter the decimal point, has decimal becomes true. This is the only decimal point in the string, so it's valid. When we reach E, has E turns true. Again, it's the only E in the string, fitting our rules perfectly. The order in our string is crucial. The sign is at the start, the decimal is between digits, and the E is towards the end, following all numeric characters. This order aligns perfectly with our validation rules. Since all characters are valid and in the correct order, our function would return true, confirming that the string is a valid numeric string. In terms of time complexity, our approach is efficient, with a time complexity of O of n as we traverse the string once. The space complexity remains O of 1, thanks to minimal variable use. Until next time.